Hello and welcome to Mr. Connally's High School Math. We've got Algebra review today, solving linear inequalities. Before we go any further though, be sure to like this video and subscribe to the channel to get information about future videos. Guidelines for using this video effectively are: watch and listen to the video, sound should be on, do not skip ahead, do not just mindlessly copy the work, pause the video when you need time to write or think, put a question mark next to problems you don't understand, rewatch and listen to the video when needed, and ask questions in class or in the comments below. All right, get your notes together and let's get started. Our key concepts for today are as follows. How do you solve for more than one solution in a linear inequality? Okay, so the thing about linear inequalities are there's more than one answer. There's lots of times in life when there's more than one possibility. Okay, you've got $20, you go to the store, you can buy more than one thing with that $20. You could also buy nothing with that. Okay, there's lots of different answers. You can buy combinations of different things. As long as you keep it under $20, you can have many different solutions to that problem. Okay, so let's look at the inequality. We know it's got more than one answer because if we were to solve it just like an equation, we would get 7x is less than 21. So we divide by 7, we get x is less than 3. This means that there is more than one answer because x could be less than 3, so that could be 2. It could be 2.99. It could be 1. It could be any number less than 3. Okay, so inequalities are different than equations in that they have these symbols. So we have the less than symbol that goes right here. We've got the is greater than symbol. And we've got then less than or equal to. It's got two conditions, and is greater than or equal to. All right, and it looks like it's got like a equal sign combined with a less than or equal sign, and they squished them together to make these symbols. Okay, also these symbols have different graphs. Since there's more than one solution, we have to use a number line to show our answer. We can't just say x equals 2. Okay, there's more than one answer. So if x is less than 3, that means we circle it and go to the left and we leave it, it's called open, because 3 is not a solution. If we want something less than 3, then 3 isn't a possible answer, so we leave it open. Okay, if y is greater than -5, then we leave it open and we would go to the right, because all the numbers greater than -5 would be to the right of that. Again, we're leaving it open because -5 is not a possible solution. Now, what if the number that you're using for your condition is also a solution? You can fill in the dot like we did here. So here's the circle for a is less than or equal to 4. We filled in the 4 and we go to the left because those numbers are lesser or equal to 4. And then for b, if the answer is greater than or equal to -2, we would color in the -2 and then go to the right for the numbers that are greater. Okay, so those are our key concepts. Let's look at them in action. Now we're going to be solving inequalities. In this one, we want to think about how can we do that, but also how is it alike to equations and how is it different? There's some key steps in here. All right, so 1/2 x minus 10 is greater than 20. One of the first steps we may want to do is get rid of that fraction. I know we don't have to, but it's so much easier to visualize the variable when it's not a fraction. So let's go ahead and multiply both sides by 2 so we can bust that fraction out of there. We don't have to do it this way, but it's really helpful. So we multiply 2 times 1/2, which would be 1x, and then 2 groups of -10 is the same as -20, and the greater than symbol stays the same, and we've got 2 times 20 is 40. Okay, now I multiplied both sides by, I used the multiplication property of inequality. Remember, it's got that name change. It's positive 2. Since I multiplied by a positive, that doesn't change the sign of an answer, so it's not going to change anything here. My symbol is going to point to the right. That'll make more sense in the next one. So x minus 20 is greater than 40, just like an equation. I'm going to use my addition property to get rid of the negative 20. And I've got x, these cancel. X is greater than 40 plus 20. So go ahead and add those together. And that's your answer. Your answer is going to be x is greater than 40 plus 20. And that's it for this one. Now let's look at the case where we have to graph the answer. It helps us visualize it a little bit more. Solving and graphing inequalities. We want to solve the inequality and graph the solution in this one. So we've got negative 3 times the quantity x plus 8, and quantity is greater than 36. Okay, so same thing we've done before. We want to distribute. So negative 3 times x is negative 3x. And negative 3 times 8 is going to be negative 24, like that, is greater than 36. Now let's look at both sides. There's nothing to simplify on the left. There's nothing to simplify on the right. So now we're going to take away like terms from both sides. This has 24 negatives on the left, and the right has 36 positives. So I can use the addition property of inequality. Okay, it's important you write these properties in your notes. It's going to really help you, especially for geometry next year. Okay, so these cancel each other out. We've got negative 3x is greater than 36 plus 24, and that's going to be 60. And again, it's just like an equation. We'll simplify both sides. We've got, use the division property, negative 3 to both sides, we get x. Now, 60 divided by negative 3 on the left side is negative 20. Now, notice what happened here. We had a positive answer up here, and now we've got a negative answer down here. It's negative 20. We changed the sign of the answer. How did that happen? Well, it's because we divided by a negative. So anytime you multiply or divide by a negative, it's going to change the sign of an answer. So because of that, we actually have to change the direction of our inequality. So instead of saying it's greater than, it's actually changing to less than. Okay, so this symbol changes from greater than to less than, or less than to greater than, depending on the problem. So our answer is actually x is less than negative 20. Okay, so because of that, our graph is going to look like this. I'll go ahead and put the two numbers you need on our graphs. For me, it's real simple. You put a 0 and then wherever the other number is. If it's negative, it goes on the left. If it's positive, it goes on the right. You don't have to put all 20 numbers to the left here in between. That's not important. What's important is you understand where the number is and which direction it's going. Okay, so we're looking for the answers less than negative 20, so we're going to leave it open. Notice I didn't color it in. And now the lesser numbers are to the left. So I go ahead and shade it in and make it very clear that my answers are going to the left. Okay, go ahead and pause and finish that problem up. Write in your notes here. You want to think about how do you graph solutions. Again, refer to the first slide where we talked about the key concepts to know how to make these graphs. All right, let's go on to the next. Last one. This is the real example 3. Marcos is saving money for a used car. So far, he's saved $1,550. He will need at least $2,210 for a used car. He plans to add $60 per week from his job to his current savings until he can afford the car. Okay, so we do know that cars have tax and other things on them, and maybe the price changes between now and when he goes to buy it. So he's going to need more than that money. That's why he says at least. Right here, at least. So that means it's going to be greater than or equal to that price. He could get lucky. It could be exactly that much, but it probably won't. So it's good to save a little bit more. Okay, so let's think about this for a second. We know he's got $1,550, and he needs at least $2,210. So that means he needs greater than or equal to $2,210. Now, what about this $60 per week? We know we add that to his amount that he has. He keeps adding it to his amount. He takes his $60 each week and puts it into his little bucket or whatever, his jar, or hopefully a bank. And that number wants to get the same as 2,210 or higher. So we're going to say it's going to be $60 per week. How do we write that? That's going to be 60 times the number of weeks. So 60W. Or we could use X. It doesn't really matter. Okay, so now we're solving for W. We want to know how many weeks it's going to take. So let's go ahead and solve this to see how many weeks it's going to take. So we've got 1550 plus 60W. We want to get the W by itself, so we'll subtract 1,550 from both sides. This cancels, and we're left with 60W is greater than or equal to this number, which would be, let's see, 0, that's 660. Okay, so we subtract those two numbers, and now we've got to use our division property of equality, and we divide by 60. So W, now we divided by a positive number, so we don't have to worry about reversing our symbol like we did on the last problem. And W is going to be greater than or equal to whatever that is, and that's the number of weeks. Okay, so it's going to take him at least this many weeks to reach his goal or go beyond it. Okay, so that means our answer is, we've got 0, we've got our number of weeks, and since it's greater than or equal to, we're going to circle it and fill it in, and then go to the right. We'll need at least to do this many weeks to save that amount of money. Okay? All right, pause to finish that last question. All right, let's review. So in summary, how do you solve for more than one solution in a linear inequality? Well, we know that since the answers have more than one answer, there can be more than one solution. We have to use these graphs. It's helpful that we understand the different symbols and what they mean, and that each symbol has a different graph. If it's less than or greater than, it's open, and if it's less than or equal to or greater than or equal to, it is a closed solution at the critical point. Okay? All right. You did a great job. Thanks for working hard. If you have any questions, please let me know. I'm here to help. Right now, I just want to tell you, excellent work on completing this tutorial. If you like this video, be sure to give it a big thumbs up and subscribe to Mr. Connally's Math and Mr. Connally's High School Math channel to get updates on future videos. Thanks for watching.
MrConnally.com